This is section 2.1, so we have jumped to chapter 2 after a couple of sections in chapter 1, and we're going to talk about equations of lines. Some of them are probably real familiar to you and some not quite as much, but we're going to go through the basics. So the point slope form is y minus y1 equals m times x minus x1. And so the y and this x are always in there. These are numbers. The y1 is part of the point, the x1 is part of the point, and the m will be a slope. That'll be a number. The slope-intercept form, most of us know, y equals mx plus b, where m is the slope, b is the y-intercept. Horizontal lines, the lines going across the y-axis, have an equation y equals b. Vertical lines, with a line going across the x-axis, this direction, is x equals a, where it's just x equals a number. Then we also have parallel and perpendicular lines. Parallel go in the same direction, exactly the same slope, they never intersect. M1 is going to equal M2 in those lines. The slopes are the same. Perpendicular, they intersect at right angles. And so slopes are negative reciprocals. The slopes you'll flip and change the sign. Let's look at a couple of examples. If you're given something with a slope of 1/3, then for a parallel line, of course, it's going to be 1/3. For a perpendicular, you're going to flip this, so it's 3/1, and change the sign to negative. If you're given 8, parallel would be 8. Flip that, that's 8/1, you flip it, you get 1/8, and you change the sign. In this one, you've got negative 1/4 x plus 8. Parallel slope would be negative 1/4. Perpendicular, you're going to flip that, 4/1, and change it to positive. So that's, and you'll probably use a little, you won't be given quite that straightforward. You may have to do a little bit of finagling and planning to get a new equation, but we will do that in the problems. The other thing that we want to talk about is the correlation coefficient. This has to do with your calculator and doing regression, or sometimes they'll call it the least squares line. And so for right now, for this moment, we're going to look at down here. So if you have points that are an exact linear fit, so when you plot them, the line goes through every point and has a positive slope, then the R value for that thing is 1, so a positive 1. If you have the same instance but it's going down, that's going to be a negative 1. For everything else, like here you've got a bunch of points and the line's going this direction, so some of them are touching it, some are closer than others. The R value will be a decimal number between 0 and 1, with the closer you get to 1. So if you had a 0.75, that's not super close. But if you had 0.98, that'd be a pretty good correlation. So that's, and then if it were negative, same thing down here, it'll be a decimal between -1 and 0. And if you have a bunch of dots where there's absolutely no correlation, then your R would be equal to 0. So we'll encounter some of that in the problem set, and we'll look at it a little bit more. So let's go look at our problem set. All right, so let's look at these problems. Number 1, find the point slope form of the line. So that's going to tell you what form you need to have your answer in. Plot the points and graph the line. So it says it's passing through 1, 3, and 5, -9. First, we need to find the slope. So m is -9 minus 3 over 5 minus 1. That gives us -12/4, or -3. So we have a slope of -3. Then we're going to plug into the point slope formula. So we have y minus 3 equals, I'm going to use this first point, you could use either one, equals -3, there's our slope, times x minus 1. And the only thing you need to do to get it in the form for Math Lab is to add this 3 to the other side. You don't have to distribute. So your answer can be y equals -3 parentheses x minus 1 plus 3. Then on the graphing tool, you're going to plot both of those points and it'll graph the line. That should take care of that. Number 2, write the slope-intercept form. So this is a different form. That's that y equals mx plus b. And we've got 2 points. We've got 1 point and a slope here. So y minus 5 equals 2.1, you're given that, times x minus a -3, so that'll be x plus 3. Then you're going to, in this one, you want to go ahead and distribute the 2.1, and then you want to add the 5 to the other side. So 6.3 plus 5 gives you 11.3. So your final answer is here. Y equals 2.1x plus 11.3. Number 3, you are given the x-intercept and the y-intercept. So you need to go ahead and find the slope with those 2 points. I've done that here, 7 minus 0 over 0 minus a -6, which is 0 plus 6. So you have 7 over 6. So there's your m. You know your y-intercept is 7 because you're given that there. So it's y equals 7/6 x plus 7. Number 4, find the slope-intercept form of the line. You are given 2 points. We'll find the slope the way we've been doing it, y minus y over x minus x. We end up with 7. So it does ask for the slope there. We'll put the 7 there. And then y minus 12, I'm going to use the second point here, equals 7 times x minus 2. Y equals 7x minus 14 plus 12. Y equals 7x minus 2. That is the slope-intercept form. And so the y-intercept is -2, so you can put 0, -2 as your point here. Number 5, find an equation of the line given that goes through these points. We find the slope the way we've been doing it. We put it in the point slope form, and we distribute here, and they do want it in slope-intercept form. They show that right here. So they tell you that, and you want to be sure that you put it in the right form. So that's 1/2 x plus 9. Number 6, find the slope-intercept form that has a slope of -9 and passes through 0, 2. There's your y-intercept, so it's just -9x plus 2. Easy to do on that one. Same thing here. Given this line, y equals 3x minus 4, find an equation of the line that's parallel to that but goes through this point. Well, the given line slope is 3. And 0, 5 indicates that that's a y-intercept. So we use that same slope, y equals 3x plus 5. Find the slope-intercept form that for a line that's parallel to this line and passes through this point. So the first thing we need to do is rearrange this one and get it into y equals mx plus b form. So I wrote it over here, and then I'm going to add 3x to the other side. Then I'm going to divide everything by 5. So this is your slope-intercept form of the given line. That tells me my slope is 3/5. So if we're writing a parallel line, we still have a slope of 3/5, and we've got a point of -5, -6. So I'm going to use these numbers and put it into the point slope form. So I have y minus a -6 equals 3/5 of x minus a -5. Clearing out those negatives, I have this. Then I'm going to distribute, and 3/5 x plus 3 is what I get. I'm going to subtract 6, and then I end up with y equals 3/5 x minus 3. That's the answer for that box. Number 9, find an equation of the line that's vertical going through -5, 4. Well, vertical means it's an x equals, so you just want to get that x part of the point. So x equals -5. And it says the corresponding linear function is. Well, it's not a function because it's an x, it's a vertical line. That is not a function, so you would choose B there. This is right one for a horizontal line going through this point. Well, the horizontal line is y equals b. It'll be y equals the y part of that. So y equals 9. The corresponding linear function is f of x equals 9. That's a constant function. Number 11, it's parallel to x equals 2.9 and passing through 14, 5.4. Write a formula for a linear function. Okay. So if it's parallel to this x equals 2.9, it's going to also be a vertical line. That's the only way it's parallel. So your equation would be x equals the x part of this one, x equals 14. But again, it's a vertical line, so we can't have a linear function to write there. We can't have an f of x equals something there. So I think that is it for the problems for 2.1. That should get you going on that.